The radial curves is the topic from the atomic structure, and most probably it will be directly asked in the JEE advanced exam, or indirectly can be asked in the JEE main exam, but the topic you need to learn is must. So generally in the radial curves, when I take the radial curves, there are three type of radial curves. First one is radial wave functions. Hope the handwriting is legible. Second one is radial probability density curves. Then the third one is radial probability density function. So generally there are three type of the radial curves, that is the radial function, the radial probability density curves, and the radial probability density function. Okay, so this is the basic point. The next point is some few basic formulas. The length of the curve is equals to number of radial nodes, that is n minus l minus 1. Now to the basic, n is the principal, sorry, 1 minute. This is the principal quantum number, and this is azimuthal quantum number. So the principal quantum number, azimuthal quantum number. Now let me, if you are not knowing about the principal, try to learn one table, that is SPDF N. 1 minute, yeah, I'm just rubbing. See, principal quantum number, this one, and this is azimuthal quantum number. And see, I'm writing N, L, M and S, a particular table. This is a quantum number table, and it can be written for SPDF. Generally n value starts from n is equals to 1 to infinity, and here it starts from 0 to infinity, and m starts from minus L to plus L, and S is only plus half or minus half. Means either the two spins of electron, means either it can be aligned in the orbital in a single unit direction or opposite direction to it, only two directions, that is plus half and minus half orientation. Next, for P, it can start from, similarly, see, SPDF based upon n value, L value, M value, S value, the graph varies. Both badya. So based on the n, L, M, S, you have these are all 4 quantum numbers, and this is the type of the orbital, sub-energy levels. These all are sub-energy levels. And I have told you this topic because the length of the curve depends upon the number of radial nodes, that is n minus L minus 1, and I have told you to know which quantum number it n, how it starts. So this is L is n minus 1, this is minus L to plus L, this is n, and this is either plus of or minus of. Okay, बहुत बढ़िया. Now I am rubbing this. The concept is not necessary, just I have told you briefly so that you are not confused with the topic. Okay भाई, चलिए. One minute here, I need to rub this on. 1 minute. Okay. Now actually see, so the number of radial nodes, sorry, number of radial nodes, this is n minus L minus 1, so the required value. Next one, the length of the curve can be determined. Next, the next point is for radial wave function. Okay, I will tell you next one directly so that you will note it simply. Okay, so remember this one, this is the important formula. This is the important formula. Next one is radial wave function. So radial wave function, how can we do it? By, see, radial wave function psi से represent करो, sigma r से. So psi is the wave function and r is distance from a nucleus. Okay, have you understood, sir? Yes sir, I have understood. Now the wave function, the distance from the nucleus is simply psi versus r, and graphs are drawn between psi versus r. This is the most important point. And the next point is both positive and negative part of graph is possible, क्योंकि means both positive and negative part of the graph is possible, means क्योंकि as this is a wave function, the wave not only travels in a positive direction but it also travels in the negative direction. So as we are plotting the wave function, both positive and negative must be considered, as it is a wave, as directly we are representing the wave with the distance from the nucleus and the wave function in a graph representation. That's all. And simply one point I need to tell you simply that, 1 minute, yeah. Simply, this graphs only represent coordinate of electron with respect to nucleus of the atom. So this only represent where the electron is, or in which, और विथ रेस्पेक्ट टू द न्यूक्लियस एज द सेंटर कितना डिस्टेंस में इलेक्ट्रॉन भी प्रेजेंट है और उसका कोऑर्डिनेट्स क्या है, यही ग्राफ रिप्रेजेंट करते हैं. और एंड सी अकॉर्डिंग टू द प्रेजेंट मॉडल वी आर रीडिंग, as the electrons are present in the 1s 2s 3s orbitals, with respect to the electron where it is present, to the distance between the nucleus, that is r, is only depicted in this graph. Okay, have you understood? Yes sir, I have understood. Next one, next concept. Next concept, for s orbital, any s, that is, it can be either in second or first or third, but if it belongs to the s orbital, the electron present or the electron we are depicting which present in the s orbital, the graph starts from maximum. क्योंकि the reason is this one, very very important reason. So let me just describe you the reason. Reason is simply, consider an s orbital. For an s orbital, the electron density, consider this as an positive. The electron density decreases, as we go away from center. For PDF orbitals, the graph starts from the minimum. क्योंकि consider example, this is also a very important example. See, reason क्या है, electron density this increases from center. Electron density increases from the center, but here reverse case. reverse case. So the reason for s orbital the graph starts from the maximum, and for pdf orbitals the graph starts from the minimum. And for this, as we are locating only the coordinates, both positive and negative part of the graph can be taken. This depicts the graph depicts only about psi versus r, that is the wave function versus distance from nucleus. Now let us draw psi versus r graphs. Psi versus r graphs. Let me take 1s graph. So first you need to take length of peak, that is n minus l minus 1 for s orbital. N is equals to 1, L is equals to 0. Therefore length of graph is equals to 1 minus 0 minus 1, that is 0. Now how to draw 0? Length of the graph is 0. Consider I have told you psi versus r you need to draw, and you need to draw against psi versus r, and I have told you for 1s another point is s orbital graph starts from maximum, and this is r is equals to 0. Consider this is the maximum, and this is r is equals to infinity. So this is the plus you need to represent. So this is the 1s graph. This is 1s graph. See, you can consider, sir, here r is equals to 0 is there and r is equals to infinity is there. This is one radial node, no sir? Radial node, no sir? How you can draw? See, that is not the case. Why means that is not the case? क्योंकि because important star point r is equals to 0 starting point and r is equals to infinity ending point should not be considered for calculating radial nodes or length of graph. Next one is two S graph. So I am considering r is equals to 0, and again as it is 2s orbital I am taking from maximum. This is psi versus r. I am taking from maximum to minimum. Now length I have told you length of graph, that is n minus l minus 1, that is 2 minus 0 minus 1, that is 1. log is 1, length of graph is 1. Now how to draw? It starts from minimum. As it is a psi function, the negative part of the graph gets involved, and this is the graph. You can see one radial node, length of graph, or number of radial nodes. So this is one radial node. So generally radial node का definition क्या है? I am telling radial node, that is probability of finding electron is 0. Means the electron will not be present here. That is an empty space where the electron is not present even in the particular orbital or in the particular shell. So that is a place where the electron does not exist. So for the particular 2s graph, the electron will not present, and this is the graphical representation of its coordinate of electron. So next I'll take some another graph, and most probably I'll complete this. Next one is 4p graph. Now I have told you that you need to first draw the graph, represent psi and this versus r, and as this is a 4p graph, as p orbital, graph starts from origin. So r is equals to 0. Now I have told you first you need to calculate length of graph, that is n minus l minus 1, that is 4 minus 1 minus 1, that is 2. Now how to do? See, this is r is equal to infinity. I have told you you should not count r is equal to 0 and r is equal to infinity. So here you can see this is 1, ये दोनों radial nodes, that is 2, hence the graph is satisfied. So in this manner we need to draw for psi versus r, means the negative part of the graph is involved, and first you need to find length of the graph, that is the number of radial nodes, and for s orbital you need to start from maximum. So that is the major points. Next type of graphs is probability density functions. So these graphs represent the density of electrons from the with respect to the nucleus, which is with respect to the nucleus, and for a particular sub-energy level. The electron can present in that sub-energy level, no? So for that one, where the most probable density exists, the graphs are represented. So this is first point. and this is psi square versus r. Graphs are drawn. Next point is graph does not take negative parts as it is square function, as it is a square function, means negative part galat hai, it will not take negative part. Next one, the graphs are drawn between the psi square versus r, and the graph density following it represents. The next point is rules for s orbital, pdf orbital are similar to psi function, that is s start from max and this start from minimum. The reason is the same, the density where the density of electrons decreases from the center, so we are considering like that. So hence let's start drawing the graphs. I will draw one by one here. See, yes, for the 4p graph only I am drawing. See, 1 minute. For the same 4p graph I am drawing. This is the